Good morning and welcome to S700 series WebEx session number 2. My name's Steve Crockett and I'm here with Gordon Ritchie. The information that we're going to cover today, we're going to go over the communications setup for the PC to the drive. We are going to work with the drive GUI and walk through the various screens that would help one set a drive up for the first time, configure it. So we'll go through the serial connections, and then we're also, that's going to take up the bulk of our time is the GUI. And then we're going to work a little bit with the website and firmware, how to get the firmware off of the latest versions off of the website if needed, and how to load them into the drive. We're going to cover the slot options that are found in the drive for the various option cards that we offer with the product. Expansion cards are important, so we'll go over those. I/O setup in the GUI, we'll go through a little bit of that. Setting up a motor file, the various components for a motor file, we'll take a look at that, and that should be very helpful. Expansion cards, we're going to go over, we'll just look at a few of them, Profibus, Circos, and device nets. There's several slots on the hardware that give us the locations for the option cards. There's actually 3 of them, and we'll cover the hardware slots 1, 2, and 3 on how to install. And then there's a few STO safety circuit option boards. I've got a simple little PowerPoint. We'll go over that, and that should be more than enough material to cover in this one session. It's quite an undertaking, so I'll get right to it. The links were given the last session for the information out on the web. I'm going to use ServoStar wiki site today for pulling firmware off a little bit later on, but for now, I'll go past. We're going to cover standard communications. So the drive talks to the setup software via RS-232. The drive has Ascii parameters that are used during the setup. So its base communications type is Ascii. The options for communication, we do have a built-in CAN chip that's in the S700. And we give you some of the information here. It is a high-speed communication style, maximum transmission speed of 1 megabit per second, and it supports CAN open standards DS301 and DSP402. The drive can be configured also for standard communications with EtherCAT and use the EtherCAT protocol. So for RS-232 communications with the PC, I've got a better picture here for that communication style. RS-232, we use a null modem cable. Our main concerns for the wiring between the PC and the drive are pins 2, 3, and 5. And we show in the construction of the cable down below that pins 2 and 3 are crossed. So pin 2 to 3 and pin 3 to 2 set up the communications, and then 5 to 5 is the ground. So that's the cable style that's expected for the Kollmorgen product, and this has been the standard for Kollmorgen since we have been doing serial communications between PCs and drives. Once you have the communications and you're using the drive GUI, this is the opening page. So what I want to do now is start up the GUI, have it talking to my drive, and show how you step through top to bottom from the wizard all the way through. And if we look across the top toolbar here on the right-hand side, you have a connect button and a disconnect. And when you see the option for disconnect, it's basically telling you you are successfully talking to the drive. On the bottom of the bottom of the screen here for the setup GUI, to the right-hand side, you'll see the drive model number, the COM port that I'm using, the baud rate at 38.4 for the communications, and it does show a green LED there, and it's online. right here for online. If you ever have any doubts whether or not the communications is working, you just basically need to check for the online status at the bottom. We have a wizard that is available for the first commissioning steps for any new system. The setup wizard comes in several different styles, the simplest being quick motor drive setup. You can see the tree on the left-hand side. It is not expanded out completely, but it is enough to complete a setup and have a motor spinning at the end. So I'll enter the setup. The basic setup screen is the one where you would think I have to choose which operating voltage I'm going to work with, how you want to manage a phase loss detection. There is some standard drive information that's seen on this screen, serial number, firmware that's presently in the drive. You've got a runtime clock, a drive alias, tells you what the current ratings are. It has a controller setting for the PWM rates, but the basic is the mains voltage and the options for it. For the drive that I'm using is 15 to 230 volt. For the high current, 480 volt is going to be an option, as well as 400 volt will be an option. So I'm using a very small S700 drive as a demo, and I am operating off of 115 volts. Okay, so again, the phase loss input, you've got single phase or three-phase power, and it's how you would want to manage it if you lost a phase. Either a warning or a fault would be issued. So anyway, that's the basic setup screen. If you need help in any of the pages that are within the GUI, the F1 button brings up online help pertaining to the page you're looking at. So I'm going to hit F1. What it does is it gives you a quick look at the page that you're on. It gives you the commands, the Ascii parameters that you encounter while you're on this page, and it gives you a simple description, screen text, and if you need to break out into more information, these are hot buttons, these Ascii 2 parameters. They take you straight to the definition and the ranges, the values for the parameter, and we can find out that PBAL-RES, it's an abbreviation here, short description, selects Regen resistor, and the parameter is used to whether the internal Regen or external Regen will be used. Value of 0 sets the Regen resistor in ohms, and so it does give you a very quick explanation. If you're a first-time user and you're starting it up, remember the F1 key is a very good help when you're trying to understand these pages and these parameters. The next setup is units and mechanical. The drive has the ability to do position, velocity, and of course acceleration, and they give you options within this screen to critique these parameters to fit your application. So I'll do a quick drop down here. You can see all the various units that you can use for position, velocity, you have several options, and acceleration, you have several options. So it kind of helps you tailor the setup to match your application. The picture here with the motor connected to a belt, if you click onto it, this being your units and mechanical, it's an additional screen that will help you get down to the more exact application information. If you have a lead screw, as you can see here, you can define what the lead screw is. It gives you the options for gearing. We have a conveyor setup. We have a belt. We have a geared belt 2. You have options for nip rolls, direct drive rotary, direct drive linear, rack and pinion, and a disc drive. And so all of these options here allow you to determine what your number of revs would be of the motor turning the load, and so you can further critique the application details and pull them straight into the setup of the drive. As you come down to this conclusion on what your application is, your mechanical conversion, you would set the number of position counts or position degrees, whichever one you choose to work with, for how many counts of position information do you want for each revolution of the motor. So it's a very valuable screen for setup, especially if you're going to do positioning within the drive. The next screen, simply motor. It's a motor feedback setup. Last most important thing is to tell the drive exactly which motor it's controlling. If you look down the feedback option list, we have a lot of options for feedbacks. Of course, I'm going to select the resolver for the motor that I'm running. My motor has already been picked out of the list, but I can go back to the database. It'll show you two options here. I'll go to the most recent one. The motor type I have is an AKM. The AKM voltage I'm going to work with, I'll just leave it at all voltages and sort through. My motor model number is AKM 23D, so I just simply come down the list. I see a 23D listed, and the choice here is AKM 23D to operate on 120 volt, and I want to see the record. At this point, it shows all the parameters that are in the drive. One most important one is the motor number, because that represents this particular motor and winding and voltage for the motor in the drive. It gives you your parameters that will complete the setup for the system. And so as I work out of this screen also helps you select whether you have a brake or no brake. Very simply here at the bottom, if you know what the load inertia is, you can, your ratio between the motor to the load, you can put the number in here. Matching inertia, I believe the number would be a 1. It's 1-to-1. And so I have basically a motor with practically no load on the shaft. I'm going to leave it at 0. It's not coupled to a load. And the only thing left is a simple, I want to perform a spin test. So for tuning, at this point it's very basic. You select a very gentle tune, a medium tune, or a stiff tune. I'll select the medium one. I'll give it a finish. And at that point, it should prompt me to save. Let's see, I still got the medium. I'm going to come up and confirm that I've got a save. Across the top on the toolbar, you'll see various buttons here from the communications. You'll see a stop button and enable button, and then there is a, looks like an IC with an arrow coming into it. That's the save button. I'll perform the save. And to confirm that my system is talking feedback back into it, I'm going to go to the tree and come down to the word monitor, start that up, and looking at position information, I'm going to rotate the motor shaft, and I can see that there are counts and activity. So I know that my motor is talking to the drive. Feedback's working. I need to enable it. All right, my system is enabled, and I do have to work on the motor. Down at the bottom of the toolbar, you'll see the word enabled. I completed the enable with the hardware enable. If I drop out the hardware enable from to the I/O of the drive, you'll see it appear right at the bottom, no HWEN, no hardware enable. Bring it back up, it's enabled, and I have torque in. The op mode that I'm working with at this point is digital velocity. Okay, so that is a simple startup with the basic setup, and I will disable, and I'm going to go back to the wizard and expand on the tree. There are several different application types for the wizards. Here you have an analog application setup, gearing, motion tasking, and the complete setup. The complete setup expands the tree in its most form. I think I will work with that and go through the additional screens that we've not covered yet. So as the basic setup, we have seen this screen once before. I'm going to walk through it. Units mechanical. All right, we do have a CAN fill bus setup screen in the event that CAN is being used to communicate with the drive. This screen is used to help set addresses, the watchdog, external watchdog, your baud rates. And so you have a screen that accommodates you when you are working with the CAN fill bus. The next screen, feedback. just to confirm, I'll move the motor shaft a little bit. There's one rev worth of movement, a rev and a half, so we are definitely talking to the motor. We do have the ability to set up a zeroing within this screen. The offset of the feedback sometimes is important, and to balance it out or to zero the feedback is necessary. So we have a screen here that gives you a simple test to zero the resolver feedback. In the units here, if I click onto the screen and actually hit the F1 button to get additional information, it takes you in to the help screen. Feedback types, I'm going to go to the offset where M phase is at. The description of it says motor phase feedback offset. It's anywhere from 0 to 360. When the feedback in the motor is set at the factory sets this. The feedback is zeroed in the motor to the correct setting, and then we ship it out. If there is any issues with the feedback or the drive, and there is a question of whether or not it is properly set by the factory, you can come back to the screen and actually use this as a test, and I'll show you that right now. I'm going to add 10 degrees of offset into the motor. I'm going to let the drive calculate what the feedback should be. I move the motor shaft off of 0 just a little bit. I'm going to enable the drive. Okay, and now I'm going to come back and actually perform a calculated offset. What I expect to see is motor shaft movement, and the offset should change from the 10 degree to the new 0 value that it finds. So here we go, and I am enabled. A warning pops up. You're about to start offset calculation and cause motion. So you have to consider this if you're coupled to loads. You may want to uncouple the load. Okay, here we go. It performs the set. So it's setting the offset value to 1, and it's having, it is repositioning the dial. There are multiple points in which this will show you 0, but it is working, and we're getting a 0 offset, or very close to 0 with the M phase. Within this screen, we have filters that can be applied for the feedback in the event there's noise in the setup from the motor to the drive. We have an observer, a feed forward that can be applied, a tuning parameter. There's filtering. Calc RK helps set up the resolver in the event that there are some offsets between the sine and the cosine that is coming back into the drive. There is a internal calc that can take care of resolver issues. We have the dial indicator showing us where we are in rotation with the motor. All right, the motor we've went through previously. The settings for the motor, my particular motor, M number is 19023, and it has adjusted my continuous and peak current. It has a thermal time constant for helping protect the motor in an over temperature situation. Based on the low voltage 115 volt power, my speed is being limited to 1500 RPM. Tells me how many motor poles is set up. 6 motor poles. It gives me the line-to-line inductance of the motor, 17.3 millihenries, and the resistance, the stator winding resistance is 8.36 ohms, and I do not have a break with it. The motor parameters that were set up by the database help create the current loop, and the current loop is shown here. iPeak P parameter, that pop-up is the actual Ascii parameter. iPeak P is set to 8.8 amps, and iPeak, that's for positive, and iPeak N for negative is 8.8 amps. We have parameters that are used specifically during the homing routine, and it's set presently to 3 amps. That is adjustable. If you wanted to perform homing with the amplifier in the position mode, you could adjust the level of current up to continuous. that you wish to home with in case you need to move a load. The I2T warning is for the current protection on the motor. The drive has the ability to monitor and measure the current in the motor at any one given time, and if the current is exceeding the continuous value of either the drive or the motor, the I2T warning setting here will fold the current back and protect the lesser of the motor or the drive, whichever continuous current is less. The I2T warning will kick in at 80% and fold the current back to protect the equipment. If it is necessary, you can adjust this value lower for more protection, or it is acceptable to take it up to a value of 100% if you need to have a little more current in the motor for extended period. It still will fold back the current if it exceeds the 100% setting. Okay, the two gains for the current loop are proportional and integral, and the two parameters are here. These proportional gain and integral gain come directly from the selection of the motor winding and this drive setup. So for the current loop gains, it's coming straight from the motor database and the motor I selected. The velocity loop screen here, we have the limits. You have a positive limit and a negative limit for the velocity. You do have a speed threshold of 5 RPM and an overspeed trip point, and these are adjustable if you need to. Maybe the application is being connected to a gearbox in this situation, and you do not want the gearbox to ever travel faster than 1,000 RPM. So you merely have to just come in and set your speeds and set your speed limits for 1,000 RPM, and you will be protecting the gearbox. Your acceleration ramps, accel and decel, we're in RPMs per second here, and it's fully adjustable if you want to limit the acceleration or increase the acceleration as well as the decel. This is the point at which to do it. Anything pertaining to the velocity loop is going to be seen in this screen. All right, the tuning of the velocity loop. We have a feed-forward gain for the velocity. It's represented in this box PI+. By default, it's set up to a 1. The proportional gain is shown here, and by the setting I previously made on the wizard to a gentle, medium, stiff selection, it set the proportional gain of the amplifier. The integral was set to 15 milliseconds. 3 filters, a low-pass filter, a high-pass filter, and then a second low-pass filter, and they are all set up for operation. In the velocity, this is to get a little bit better a definition for this. I'll hit an F1 button, and I'll come down to, let's say, the proportional gain of the velocity loop, the GV, and the description takes you to a little bit higher level. It says velocity, current loop, proportional gain. It gives you the range that the parameter can be set in. It gives you a little bit of detail based on the current rating of the amplifier. So additional information can be had. Remember the F1 button. Okay, so we will be tuning in other sessions. I think the next session is the more advanced. We'll go into a little bit of more detail on the tuning, but for right now, just showing you where these are, that's the purpose. Deceleration, disable behavior error. The two boxes here have, this is pertaining to a controlled stop, and it gives you the ability to set the amplifier up to, if desired, the controlled stop will, or if a fault occurs within the amplifier, do you wish to immediately stop the system under control before disabling, as it's showing here, decelerate after the fault and then disable, and it gives you an additional ramp to set the rate of decel? Or do you want to disable immediately and let the system coast to a stop? So if it's a rotary Ascii and you can live with it coasting to a stop, then you may want to just disable immediately. But if you had limited travel and you have very delicate equipment connected, you may want to decelerate in a controlled fashion before you disable the power stage. And you may want to set the decel ramp to the appropriate value so that you come to a stop very quickly if you're at close to the ends of travel. Same thing can be managed for this next parameter. It's called stop mode. And basically, if you command a disable of the amplifier, if you do not set up the stop mode, have mechanical limits, it could same thing, it could drift to a stop. And if you have decelerate then disable, when you go into your stop mode or you're disabling, whether it's hardware or software, it will bring it to a stop before it turns off the power stage. So these two settings also have additional ramps for decel rates, and they reside in the velocity loop screen. If you're operating in the position mode, you have the position loop screen lets you set the proportional gain and, if necessary, an integral gain for the position loop. Typically, you only use one integral gain. If the velocity loop, I'll jump back one screen here, if the velocity loop integral gain is being used, then most of the time the position loop screen will not require an integrator, because that would cause the system to struggle over who's got the control, either the velocity loop or the position loop. So most of the time the integrator is set to 0. You do have a feed forward parameter for position. There are options for secondary feedback on the machine. Maybe on the mechanical of the machine you've mounted an encoder and you want to bring that in as your primary position feedback. That's what this one screen right here would be, is a secondary encoder, not the feedback in the motor, but a secondary encoder maybe on the mechanical parts of the machine are brought in to perform the positioning. Position data is used when you are wanting to perform positioning within the drive. Op mode choice would be position motion task. Define whether you have linear type application or a modulo. The linear is used if you do not need to define your ends of travel for rollover purposes. Modulo, if it is selected, you have a starting point for position and an ending point for position that helps manage the position counter. So if it was 3 revolutions of the motor and you want to roll over the number of count, we previously set the position units mechanical. I can jump back to that screen. Position mechanical was set to 10,000 counts per rev. I go back to my position data screen and select modulo. I could state that I want the system to start counts at 0, and at 30,000 I want to roll over the counter back to 0. For maximum following error, knowing that we've got 10,000 counts per rev, this is the default value, and it is saying that we would allow 26 revs of the motor before we report a position following error. So most of the time this is needing to be set to a smaller value. I'll set it to 10,000, which would say within 1 rev of the motor I want to be aware of following error. In position is showing at this point 4,000 counts, so 40% of a rev is within position. A lot of times this needs to be narrowed down, maybe to 100 counts, so that you're more accurate and the in-position window or registers may be looking at the position, and 100 counts when you're coming up on your final position is more desirable than 4,000 counts. Acceleration max for position, we are in RPMs per second, so you may want to adjust the RPMs per second to some rate that you want your positioning to work with. The velocity limit we set to 1,000, so I would think you would also want to match your maximum negative and positive position velocity to the same. This information is giving you the details of position data that you would work with when creating motion tasking. So you're setting your rules or your guidelines with this position data prior to you going and building motion task profiles that you are going to execute from within the drive. We do have software limit switches that are shown here. You can activate them and set the software limit switches to help prevent over travel. Most of the time inside of the hardware over travel, you can set up your software over travel for positive and negative. Position registers can be used and set up here. This is for changing the state of outputs based on motor shaft position. I'll do a quick enabling without CAN, and it enables, it gives you the options of always turning on or a single shot of turning on the output. You can enable it, and it gives you an additional, if the signal is greater than or equal to or less than and equal to, and some number, some count, say half a rev, and then we would change the state of the number one position register. That could be tied in with digital I/O, and you could get an output when you are within the range of that position. Electronic gearing, the system does have the ability to perform electronic gearing. The source of the gearing is your first choice here, and so it's merely a command type coming into the drive. Most of the time it's in something like a pulse encoder format. As you can see, the choices here direct the encoder signals that we are going to be gearing with as a command to different connectors, and so the drive has various points at which the encoder or the geared encoder signals can come into. Most of the time it's based on the voltages that they're operating with. So we have a pulse and direction that can be brought into X3. If you had a 24-volt encoder, you could actually bring it into connector X3. If it's 5-volt sine type encoder to be geared with, it can come into connector X1, and that's assuming that X1 is not where the feedback of the motor is being brought into. So these inputs, this setup for gearing, pretty straightforward once you get into it. We do actually have a wizard that helps you set up electronic gearing. Then the revolutions per resolution or lines of count, you have to define that. It also gives you a filter for the gearing function. A lot of times you can get a very granular performance of the system when it's responding to encoder signals coming in. So we give you an additional filter to clean up noise or digital noise that may be coming in with the encoder pulses. So it's very helpful to help smooth things out. And then you have a count direction. Encoder emulation. Next screen, we have a resolver-based feedback in my motor, but we offer out an emulated encoder signal that can be taken to a position loop or a control external to drive. The format for that encoder can be selected here, and basically when you select, and the ROD is a representation for a pulse encoder output, and you merely have to state how many lines per rev you wish the emulated encoder output to create from your resolver in your motor. So if you want 4096 lines per rev, you're going to have, that's pre-quadrature. You have 4 lines, an A, an A naught, a B naught, that will be outputted at 4096 lines per rev So your total number of pulses to your external encoder would be 16,384. So it's very helpful to have the setup for emulated encoder out. It saves time and money with the system, and it gives you the flexibility of adjusting your resolution to whatever the application requires. In the event you want your control to set up, control the motor with an analog input, this is the screen we would set the range on. You have numerous choices for your analog inputs. They happen to be 2 analog inputs. Many choices here. The F1 button will break it into a little more detail on analog inputs. You can see the Ascii parameter is analog config. I'll take a quick jump to that. Now all of the choices that you have, which look to be as many as 14, are given in a better description. They give you a little more detail on the description as you're making your choice, which analog input do you need for your application. So the F1 button provides good information here. The analog velocity is selection for op mode is in the upper right-hand corner. We have the ability to do an automatic offset if there is drift or a small millivolt type signal that is coming through from the controller. You do have the possibility of performing an auto offset. If I enable my system, all right, this is something that has come up here. As the changes I've made through the wizard, I made changes that were critical to the system, whether it be some of the basic setup or determining the velocity loop, deceleration rates. The parameters were changed that are critical to the system. They're called configuration parameters. And as I've made changes, say to the analog input here, you have to perform what is called a save and a cold start, and the drive prompts you with this task that needs to be complete. So the first choice here, well, the only choice at this point is giving the permission to proceed. So I'll give it an OK for the save and the cold start. What's occurring on the front of the drive is a save and a cold start is cycling and the logic power to the drive. So it appears as if I had reached up and turned off my logic power. The display of the drive went blank for a very brief time, and then it starts back into the power up sequence. All right, so my drive is back up under power and analog velocity, and I have the motor rotating at this point. I'm giving it a small analog input, and you can see the dial rotating in the counterclockwise direction. So my system is up and configured. So I'm going back to the analog screen, and at this point I have a scaling of 3,000 RPM per 10 volts. If I change that down to my velocity limits, I'll go ahead and set them both at 1,000 RPM per 10 volts. If I wanted to monitor the amount, let's see, the RPM that I'm rotating, if I increase the speed to where I see 100 RPM, I'm at 100 RPM. I can go right here is the actual velocity right there, 100 RPM. And if I look down to my analog input number 1, I've scaled 10 volts for 1,000 RPM. So right now I'm at 991 millivolts, right at 1 volt for 100 RPM. And that was done in the analog input screen. If I scale this back to 500 RPM per 10 volts, I'll check that screen once more, knowing that my analog input is at 1 volt, and I'm back to 1/10 of that. So 1 volt worth of input scaled should give me 50 RPM, and that's right where my actual velocity is showing. I'm right at 50. Okay. So that's the analog input, scaling, digital I/O. Okay, for this I'm going to disable the drive. The digital I/O gives you 6 inputs that can be configured. The choices are numerous here. And again, you have the most popular one. I'll do a quick reset. And this is changing an analog input. If you look at the end of the pop-up screen, this is what pops up. At the very end, you'll see a small C, and that stands for a configuration parameter. So that tells me that if I make a change in this digital I/O screen, I will be asked to perform a save and a cold start in order to get the system configured for what is at this point a hardware change. So I'm going to leave this at reset. I'm going to choose one output to have the actual velocity, let's say less than 100 RPM. And I'm going to give it a finish. And again, that's a configuration parameter. If you look to the right of the pop-up box, you'll see a small C. So when I say finish, immediately I get the drive notice that I've changed the configuration parameter and I have to do the save and the cold start. So I'm back online and I'm enabled, and I want to go to the monitor screen. All right, we configured the analog output number 1 to be on when it's less than 100 RPM. If you notice right now, my actual velocity is at 50 RPM. Therefore, I'm going to have this LED that's outputting or turned on, and I'm going to increase the velocity beyond 100, and the digital output turns off. And right now, my actual velocity is 110 RPM. So the digital output programmed is working well. I'm going to generate a fault on the drive. And we'll go into more detail in a later WebEx on creating faults, but I want to make sure my input number 1 that I set for reset faults is going to work for me. So I'm going to pull the feedback and create a fault. Okay, status, errors, and warnings. I've had a feedback loss condition, and at the same point I had an overspeed condition. And what I want to do is clear the fault. So presently my drive is flashing an F04 and an F08 on the display. I'm going to go back to the monitor screen. I'm going to toggle the input, number 1. And that input should reset my fault. Input number 1 came on. Now I'll go back to my status for errors and faults. You can see that the errors and faults are clear. I'm online. I am disabled. Enable. So my reset input worked for me on the digital I/O, and the digital output worked for me as well on letting me know the RPM of the motor shaft when it was less than 100 RPM. I want to finish out and show you a few of the screens that are remaining on the left-hand side on the tree. There is a motion service screen that allows you to perform a simple jog. The op mode, presently, the op mode in the upper left-hand corner here is analog velocity. The motion service screen works with digital velocity, and what I'm going to do is disable the drive with the software. See, the velocity stops. I'm going to change the op mode to digital velocity, and I'm going to use the motion service here to just jog the motor. Okay, I'll set it up for 10 RPM. I'm going to, right now I have no software enabled, so we're not enabled. I'm going to bring it back up. We're enabled, there's current in the motor, and right now our velocity is holding right around 0 RPM, dithering a little bit. Now here comes minus 10 RPM. warning in case you're connected to a mechanical load. The warning pops up and it notifies you that you're about to cause motion. I'm going to say yes. I know I'm not coupled to a load. And if you hold the button down on the jog, you can see that the RPM is right around minus 10 RPM. If you come off of the button, you notice that the RPM goes back to 0. So the function will only work if you're hovering over the button and pressing on the mouse button at the same time. You see the color change and the RPM. I'm going to increase the speed just a little bit so you'll know it's happening. There's 100 RPM, and now you can see the velocity is minus 100 RPM. All right, I'll go to plus 100, and I'm holding the button down and I'm hovering over the plus, and you can see my RPM is remaining fairly constant. Okay. All right, we do have the ability to jog in a position mode, and if I change the RPM to 200, basically the only thing you're going to have to do is go over the button which you want to have the speed. I'm going to run down to position, motion tasking, the position mode, and I'm going to jog at minus 200 RPM. And the motor's turning very quiet. Looks like we're oscillating a little bit. Maybe my tuning is, no, it's fairly smooth, to tell you the truth. It's just jumping around quite a bit. You can see the position is decreasing from 180 some thousand, actually 1,700,000, 1,600,000. It's counting down. All right, go to the plus. All right, now we're increasing in count. So the positional jog works very well. You just need to know what your mechanical load's doing at the time you're using this function. If you drag your pointer off, it does stop. Okay. All right. So that's the motion service screen. Now we're going to go, we'll just jump in and out of the, we just was in the status errors and warnings. Anytime you have a fault on your drive, it will display a F on the 3 7-segment. There's 3 7-segment displays on the front of the drive, and so the Fs represent the faults. And if a fault does occur, it's logged into the fault history. The fault history retains the last 10 reasons why the drive shut down. It gives you a timestamp. There is a runtime clock, and it gives you a timestamp at when the fault occurred. And there is a frequency counter on the right-hand side here for the most frequent faults that have occurred. It starts recording and logging in. It shows feedback loss once right here. I caused that just moments ago. If I reach up and pull my feedback one more time, it logs in a second one has just occurred. So you get your faults and the frequency increased by 1. And all I have to do at this point is use my input number 1 to reset the fault, and I should be back up and ready to operate again. Okay, so the status shows you what's happening within the drive and the history of how many faults have occurred. It's good troubleshooting, and we are going to cover troubleshooting in the next session in more detail. You also have a troubleshooting help guide. If you go to it, it breaks down the various reasons, for the different faults. The F08 was one of the faults that I recorded, and of course it gives you a description of overspeed, and it goes into some details and some helpful checks to look at to try to correct the problem on the servo system on the S700. Okay. We also have warnings in the drive, and from this screen you can see warnings are represented by the letter N followed by a number. And a warning is not a fault if a condition causes a warning, such as a foldback of the current. If you exceeded the continuous current of the system for too long, then you could end up with an N01. And an N01 is telling us that the I2T threshold has been exceeded, so you have excessive current, and the warning is present telling you you're running with limited current. It causes things such as position error or something additional on the machine, or the higher level control may trip out due to the fact that the motor doesn't have full power to move the load around. So the warnings, if the condition is corrected, such as the demand for the current goes away, the warning would disappear from the front of the drive. So the N01 would no longer be flashing and the current would no longer be in limit if the demand for the current goes away. Okay. All right, the monitor screen, we've been in and out of it a little bit. The monitor screen basically breaks down all the key elements of the servo system and puts it in a single location where you can watch things such as the amount of I2T for the drive in percentages, or the motor, the I2T load of the motor. The effective current is the actual current in the motor wire. The D and Q component are elements of the current for the control. They're listed here as well. The bus voltage is present. Since I'm working from 115 volt AC, you're seeing a 166, 167 volt DC bus that I'm using to drive the motor with. We have a Regen power monitor here, where if we were in Regen, you would see the percentage of wattage that is being caused each time the system goes into Regen. We have two other wattages here for electrical power and mechanical power. They've added those recently to the software. And then we have power consumption displayed as well. On the right-hand side, we have the drive's heat sink temperature, and we have that's on the actual heat sink, a thermistor is mounted to the heat sink, and we have a thermistor in the environment inside the amplifier housing, as if it was a component up off of the board. So we call that the internal temperature of the amplifier. Of course, these do have thresholds. If they're tripped, if they are exceeded, they will shut the system down. Motor thermistor resistance, there's a temperature sensor in the windings of the motor, and it's coming back to the drive and displaying it in ohms. It acts a lot like a thermostat. If the motor gets too hot, the resistance goes very high. It's a PTC device, and it goes very high, and the system will shut down with a motor over temperature. So we're monitoring the thermal properties of the motor and the heat sink and the enclosure of the amplifier here. We also have angle of rotation, degrees mechanical. We have counts that is actually being displayed in a hex value. We have actual RPM of motor shaft. We have the velocity command and the position of the motor shaft from the 10,000 counts per rev that we initially set up. And then there's following arrow displayed here as well for position, following arrow. User-defined variables, you can actually come in and type parameters that would give you the information that are parameters that you might be more interested in for your application if we don't cover all of them up above. These Ascii parameters, you would have to go to the Ascii guide. If you hit F1, you can come into the Ascii object reference, and if you select the object reference, it will pop up and it gives you A through Z. If you look here to the left, A through Z, every parameter that is used inside the amplifier. And if there was parameters that you wanted to monitor, let's see if I can grab one. I'll try the DIR parameter. It is a read-write. So I'm going to try DIR in one of the monitors here. And let's see, does it give us a value? It does. It gives us a value of 21, which just represents the direction of motor rotation. So some of these parameters, you would have to just give it some thought on what you would want to plug in to each of these 6 user-defined parameters for your application. All right, analog input, we used that earlier. I can sit here and adjust my analog input, and you can see it changing on IN1. We also have an analog input on IN2. So it's very, very helpful. Down at the very bottom, we have representation of the inputs and the outputs, as well as the STO1 and STO2 status, the safe torque off. So it's a very good screen to come and get a quick idea of what's taking place in the amplifier. Homing screen, we'll go over a little bit more in the next WebEx session. When we do positioning, of course, the drive would have to be homed prior to doing positioning, and this screen gives you the tools to perform that. Positioning, as we mentioned, motion tasking. This will be the screen in which we will come in and actually build a couple of motion tasks. And I'll double click into this one box here. Kind of shows you how to come in and select and build a profile for position that you want to save to the drive for motion task number 1. So this screen helps you set up all of the positioning that you may want if you're using the drive as an indexer. Okay, oscilloscope screen. The oscilloscope screen is very helpful. It's going to take a little bit more time to use it. The next session we will go into more detail with the oscilloscope screen, but basically we have the ability to run 4 channels, save them. These 4 channels, you can trigger the events from the servo system and store the information. You have the ability to load and save what is being recorded for future reference or for benchmarking performance on a machine. Or even if you're troubleshooting, you could save off a recording and email the recording to me here at the KCS or any guys in the L2 group and help explain what your problems are on the mechanical Ascii with the servo driving it. We do offer motion servicing, which would allow you to start motion from within the oscilloscope screen to record with. There's lots of choices here for your motion service. You do have the ability to come in and tune from the oscilloscope. You have the choice of all the velocity parameters along with the position tuning parameters, and even the feedback screen where you have filters to help. All the tuning can be done from within the oscilloscope screen. We also have a small terminal screen that's been added to the oscilloscope so that you can type in commands and get immediate answers on the display here. So we've added quite a bit of detail into the oscilloscope screen, and we will be working with it more next week. Okay, Bode Plot. The screen gives us the ability to perform a Bode test to check the bandwidth performance of the system along with phase margin. So gain and phase margin test to see how well it's performing or how to look for the problems that may be occurring with mechanical Ascii that the servo's driving. And it would assist us in the method of helping select filters to maybe attenuate frequency issues that exist. The Bode gives us an inside look at what the problems are for resonance and performance of the servo system. Okay. Terminal screen, same as what I just showed you in the oscilloscope screen. If I enter the command ver, it should come back with the firmware version from the amplifier that I'm now connected to. So I'm running firmware version 5.38. Okay, so there are lots of parameters. As I've showed you before, the Ascii object list, if you hit the F1 key, takes you straight to the Ascii object list. Any of those parameters can be pulled into the terminal and typed in for immediate response to the settings or what their statuses are. Okay. We do have an auto-tune screen that allows you to perform making some certain select choices here on how to perform the tuning. It will automatically sample the load, move the load, and appropriately set up the velocity loop proportional integral. It sets the feedback filters. The velocity loop observer is being set automatically. We have 4 filters that can be adjusted automatically. We will be going over this next week in the 3rd WebEx. So just a brief mention on it. And we have last 2 screens, EtherCAT communications methods. Then there is an SD card that can be used for setup. Hopefully I can put something together and include this in the next session for the WebEx. The SD card gives you a very simple method of downloading parameter files from one drive to the next without the use of a computer. You can download with an SD card. Okay. All right. So that kind of wraps up where I'm at with the with a quick drive-through. I know it wasn't real fast, but it was more thorough. We did a pretty good drive-through. Let me check my notes here and see. Okay. Where are we on time-wise? Okay. So we've got quite a bit of time left. What I would like to do right now is go through a firmware download, and I want to pull up a copy of the firmware. So here's the web link to the wiki site, and I'll walk through and show you how to reach the S700 firmware. So we're looking at the firmware and the table of content, software, drawings, and I want to go to firmware archive. They have laid the firmware archive out so that you are looking at the firmware versions. On the left-hand side, the hardware versions for the 2 different hardware platforms, the low current S701 through the 724 is shown, as well as the S748 and the S772 is shown. And if you come to the bottom of the page, you should see the hardware version is at 2.10, actually for both the low current and the high current. And to the left of that, we have firmware version 5.38. And the reason why I'm looking at 5.38 is I believe the 5.46 is a beta version. I'd have to confirm that, but I'm thinking that to be safe with this, I want to use the 5.36. Open that up. I want to do a save. And I will put it on my desktop. Do a save. And I'll give it a yes. So it's putting the zipped version onto my desktop. At the very top of the toolbar, you have Upgrade Tool. And because you're going to use the same serial connection between the PC and the drive, you have to turn off the communications or choose to select the communications to be ended from the commissioning software. So I'm going to relinquish, is that a good way to say it, the use of the GUI. And you can see in the background here where my mouse pointer is, or right here, I have a gray bar in the disconnect, and it's showing that I am disconnected because the only one that is selectable is the connect button. So now up pops the upgrade tool. I want to go to the S700 product. I do want to use COM1. I am going to perform a firmware download, and I need to do a browse and download, and I'm looking for my desktop, and the firmware was 7REL538. I pulled that into the screen, the firmware to be used. I've disabled my drive, and I'm going to open it, and it wants me to check my 24-volt connection. Only 24 volts is required when doing firmware downloads. I'll give it an OK. And it is preparing the drive for download 100%. And it now is resetting the drive. The drive display is back to a normal state. And on the download, I have the download screen. I show green, and it reports download procedure finished, download succeeded. So we've successfully downloaded firmware into the drive, and I need to go back and reconnect the communications for the setup software. All of the files, everything that was in the drive prior to the firmware download is still intact. My motor file is still intact. All the tuning, all the velocity loop tuning, and the setting for the speed limits and everything that was done previously were unaffected by the firmware download. A good idea to save off a copy of the drive file, and I'll show you how to do that at this point. You merely have to come into the upper left-hand corner to where it says File and Save. It takes you to a location pre-assigned by the load of the drive GUI, and I'll name this WebEx Session 2, and I'll perform the save. So now I have a backup of everything that we have done today. All right, the next thing that I need to, we want to look at the slot options. When you have the standard amplifier and you are wanting to add an option card to it, you have to remove the, on the front of the drive there are three possibilities for plugging in option cards. Option card slot 1, slot 2, and slot 3. And last week I told you that slot 1 and slot 2 occupy the same hardware location. So you could never have option card slot 1 in use at the same time as option card slot 2 in use. It's one or the other. So I'm going to show you today what the steps are for preparing the drive to install an option card. The slot option here we have is a Circos card, and of course Circos is a fiber optic type communications network that will require an external master to communicate with it, and then the Circos option card is installed into the drive in order to have it function within this Circos environment. We also have options such as Profibus, and Profibus is just another bus structure that we use to support Profi drive profile. And then we have DeviceNet as an option card, and it is another possibility for high-speed communications. Okay, so page 121 in the hardware manual, you will see in front of you here expansion cards for slot 1. So the first drawing here, it shows slot 1 in the position, the upper position of this overlay. This is the front of the drive, and it actually is labeled slot 1 right on the front of the drive, and it's shown here in this red box the actual position the card would be installed in. They call this the boundary of slot 1. If you remove the film that's located, it would require you to it's already formed, and it has an adhesive on the back, so it is stuck to the front of the drive. You merely have to go to the edge and lift it off. So it's, as it states here, detach the film on the front, and you peel it back out of the way. The point at which you want to stop is right at the bottom, as shown in this drawing. Tear off the film as far as this mark, or the mark. Okay, that's the position for slot number 1. And then it shows taking a screwdriver and actually breaking the tab that's found on the left first. It's a heavier piece of metal, and you need to break it first, as well as the second one down there on the left. You would break that second tab on the left, and once that is broke, you can reach in and actually lift up the metal, and you pull the tab out. There is only 2 remaining pieces of metal on the left-hand side, and they will easily break out. And you need to make sure you're only breaking the top 2 perforations here, so that it comes out and relieves the slot cleanly to install the option card. And the one key thing is you want to make sure you are leaving the bottom mounting screw for that option card to tie into, because there are screws to retain the card into place, secure the card into place. So you have to make sure you're only breaking out the upper 2 tabs. And you need to know 100% that you are installing your option card into option card slot number 1. And beyond page 121, it describes each of the option cards that are allowed to be inserted into slot number 1. The next page for slot number 2 is 137. And so almost identical steps for preparing the drive for option card to be installed in slot number 2, except in this picture here you can clearly see it's on the lower half of the drive, the slot. And again, the cards are called out that are allowed to be installed in option card slot number 2. So again, put some clear thought into the process of which option card you're going to use and which option card slot you need to prepare to install. And then the last option card slot position is number 3, and that's found on page 147. This is a separate slot all to itself, so there's no overlap here on option card slot number 3. And the same method of preparing the drive for option card slot number 3 to be removed, it's exactly the same as in number 1. You just remove the overlay, the adhesive overlay, and then you reach in and you break the metal formed tabs as described in slot number 1. And beyond that, we have a clear definition of which option cards can be inserted into slot number 3. And page 41 covers the function of the STO, and as it states here, frequent required application task is safe torque off and the protection of personnel against unintended restarts of the drive. The S748 772 amplifier offers, even in the basic version, a 2-channel STO function, safe torque off. The function blocks the ability or the triggering pulses of the transistors. So in other words, it prevents the transistors from receiving the pulses to drive current into the motor. So slot number 3, the last one we covered, was basically for installation of the safety card into the STO. The simple description, it's only 2 inputs that the drive will manipulate. The STO card brings in external safety and the ability to meet the SIL levels that come in with the safety card. External wiring and external master controls are going to be necessary in order to complete the function. If I go back to the STO card 47, it's showing, you see a picture of it here, the expansion card for safety 2. The card has several functions that will be used, but as the drive expects it, it's only going to be turning on and off the 2 inputs. I don't have a lot to say about this card, so I don't want to drag this out too much more. Primarily was after the fact that we want to get the installation right, and slot number 3 is for the STO cards 1 and SIL1 and SIL2.